All right, welcome to this lecture series, I guess. So let's talk about macromolecules. This is the chemistry of life. This is the complex stuff that we need to start talking about. So, what are the macro? Let's look at this question right here. What are the four main types of macromolecules? If you look at, if you look at this part of the word right here, this macro is the opposite of micro. It means large, and molecules. That's what this part is. So, what are the four large, important biochemical molecules in your body? Let me ask it a different way. What are the four macromolecules we put in our body? What are the four things that we talk about chemistry-wise when we eat? Okay, so you saw one of them already. One of them is carbs. Okay, so when we talk about dietary needs, what are the things they worry about? Well, people worry about carbs. There's a lot of talk about low-carb diet. Lipids and fats, although tasty, this is the biggest culprit. We talk about trying to lower our calorie intake. Fats and oils are your biggest culprit there. Proteins, obviously. We hear a lot about weightlifters who want to build more muscle mass. Muscles made of proteins. You got to eat more of them, right? And lastly are nucleic acids. This is one you don't really hear a whole lot about, nucleic acids. But anything living is going to have these. So they're a very, very different group. So let's look at these. Once again, like I said, macro meaning large, molecule. How they're made, another word for a macromolecule is a polymer. Poly means many, and mer just means something made of lots. And if you look at this, all of those aforementioned groups here, all four of these, are made of monomers and polymers. So they're very large, as I mentioned. One little piece, so each of these, think of pearls on a string, for example. Each individual pearl is a monomer. The polymer would start to string them together. So you can see monomer, and then all of this together would be your polymer. We eat the polymers, we break them down into monomers, and then our body uses those however we need to. A lot of times, it's kind of weird. You eat like a carbohydrate that's really big and complex, you break it down to the simple carbohydrates, and you just put them right back together so that you can store them. Sometimes we break them down and then rearrange them into something else. That's what metabolism is, taking these molecules, breaking them down, and building them into something new. It's kind of like when you have Legos. You might have a big ship, a big pirate ship made out of Legos. When you eat like proteins, carbohydrates, lipids, things like that, you break them into smaller parts, rearrange them, and then put them in your body where you need them. That's metabolism. So what's the exact process we do that? Well, the first one, this is how you put polymers together. Dehydration synthesis. When you synthesize something, you are creating it. Dehydration, sometimes called condensation. The reason for that is you can tell from this right here, you have an OH and an H. OH, H, OH, H, H, OH. Right here, you can actually pull this off and remove water, and it will stick this together. So here's a short polymer and a free monomer right here, and you stick it on there, and all of a sudden, you've got a longer chain. So how do you link monomers to make polymers? Test question. You do that through the process of dehydration synthesis. And what is being released? You release water. I don't know really, I have a lot of analogies. This clicked for me when you think about if you have a muddy shirt or muddy shoes. That's probably a good example. When you have muddy shoes, you have mud, which is made of dirt and water. If you leave them outside and they dry out or they lose water, you've seen that now the mud is much harder to get off. It's stuck on there. It's been polymerized. That's basically what happens here. So in this case, in the case of dehydration synthesis, this case, where you're linking monomers, monomers are being, I don't have it on there. Monomers are being strung together, and polymers are being elongated, I guess. Monomers are being used, polymers are being made, I guess. The opposite of this would be hydrolysis, and as you can tell, you are now adding water. You add water to this bond right here, and all of a sudden you have broken that. It means to hydrate. Just like if we go back to our shoe analogy, if you took those shoes caked in dirt, which is now dried out, you would want to add water. That's why so much of cleaning, when we do dishes, when we wash laundry, when we're trying to wash anything at all, One of the best things you can add is water, because it will break most of these polymers into their monomers. So what is being added? Water. What is being, are you building up or breaking down? What do you think? Are we building or breaking? We are breaking. You can see that this is now free. So this is a lot of what happens when you digest food. You get these big long chains of carbohydrates or big long chains of lipids or chains of proteins, and you just start adding water and you start breaking those polymers into their individual monomers, and now you can actually use them. So monomers are being created in some sense, and polymers are being broken down. So those are the two processes of dehydration synthesis and hydrolysis, how polymers are either made or broken down. So let's go, that's the same for all four of these, for carbs, for lipids, for proteins, for nucleic acids. That process of hydrolysis and dehydration synthesis is going to be how you string monomers together to make these polymers. So this is the concept map here. You have those four we talked about: nucleic acids, proteins, lipids, and carbohydrates. And you can see, well, this is a really good thing to use as a study tool before a test or before a quiz. So let's talk about this one right here, carbohydrates. This is the simplest. They are simply sugars. What are carbs? They are sugars. You know what they're used for. They are used for energy. We use this is most organisms on this planet's source for energy. And there are kind of three types here. Monosaccharides, as you can guess, this word mono here means one, sugar; two, disaccharides, two sugars; poly, lots of sugars. If you kind of think of having a bunch of money, especially like $100 bill, and then you have some 20s and some 5s and some 1s. These monosaccharides are for $1 bills. They're super easy to use. They're already broken down, so your body uses these readily. If you have things that taste sweets, they have lots of this. Basically, your number one carbohydrate is going to be glucose. They are just your simplest, most basic sugars. They taste sweet, and you get energy very quickly. They're already broken down, so you can use them very easily. Disaccharides are double sugars. They're like sucrose and lactose. They still taste kind of sweet, and they give you very fast energy because they don't have to be broken down very much. Just kind of like a $5 bill. These polysaccharides are like your $100 bills. Tons of energy, but very difficult excuse me, to use because they are not broken down. You have to break them. You know, you go to a restaurant, can you break 100? No. You have to go break it down to 20s and then 5s and then 1, then you can use it. So this is anytime you're going to have more than 2. So 3 and so on. These are things like starches and cellulose and fiber, glycogen. These are your breads and your rices and your pastas. This would be, hey, why ain't it working? There we go. This would be your, these are kind of not, you don't hear a lot about these. These are your really sweet, fast acting. That's why runners carb load. It takes such a long time to break these polysaccharides or these starches down. It takes you so long to break them down that you actually have to carb load 1 to 2 days earlier because it's going to take your body a long time to use that hydrolysis reaction I talked about to break those down into pieces that you can use. So here's an example of what a monosaccharide looks like. Most of them have this kind of hexose shape, 1, 2, 3, 4, 5, 6. Well, that's not the real best way to do it, but you get the idea. They all have this kind of hexagon shape. So anytime you see those drawn in any textbook ever, you know that you're dealing with a carbohydrate. Here's a monosaccharide. This one happens to be glucose. Here is sucrose. This is a really, really sweet sugar that you've probably tasted before. So that's a disaccharide. Look, it's got a pentose there. 1, 2, 3, 4, and there's your 5th sugar right there. Or 5th carbon, excuse me. So that's your disaccharide, and this is amylose. This is a really long, complex carbohydrate. If you may have noticed glucose, sucrose, fructose, maltose, lactose, amylose, they all end in ose. That's a good thing to note. You might want to write that down. If it ends in ose, it's a sugar. It's a carbohydrate. Oh my God, lots of words here. I'll do this real fast. You know what? No, you can read this on your own. Here's a picture of foods that are really, really high in carbohydrates. Breads, fruits, pastas, potatoes, corn, grains, rices, all this stuff right here. Here's monosaccharides. I want you to get a good look at how these, there's a few of these here. Note the shape. Single sugars, double sugars. Oh my God, look. We're going to take 2 of these monosaccharides, pull out the water in monosaccharide, monosaccharide, disaccharide, monomer, monomer, polymer, just like that. Very simple. Oh, there it is. Right. Oops, come back here. There it is right there. Monomer, monomer gives you polymer. Monosaccharide, monosaccharide, disaccharide. Here's another test question you'll need. These are examples of 3 different disaccharides. You need to have these memorized. I might just say, if you add a glucose and a fructose, what do you get? I might say lactose is made of what 2 things? Glucose and glucose make what? There is a trick. Glucose, fructose, glucose, galactose, glucose, glucose. All of these disaccharides have the same monomer in them. They all have glucose, glucose, and glucose. So as long as you can remember what the other one is, you're gonna be safe. So these polysaccharides are the big, long, crazy, complex sugars, sometimes called starches. Mr. Archibald, what's the difference between a polysaccharide and a starch? Nothing. They're the exact same thing. Super long-term storage, but still not as much as fats and oils. They have extremely long terms. I read this the other day that, if you, let's say you suddenly were dropped on a desert island and had no more food, you should have enough blood sugar floating around, enough glucose in your blood sugar, to last you about 4 hours if you don't eat anything at all. After 4 hours, you then have to start breaking down these longer starches, this glycogen. This is one sugar that isn't in the oats. You will basically start breaking down that glycogen, which will take forever. You store it a little bit, and your body will slowly break down glycogen into glucose. And that takes a long time. That takes like 2 days. If you have any residual or excess carbohydrates in your blood from the earlier meal, you will start to break that down as well. So any pastas, any starches, grains, or rices that you've had in the last 24 to 48 hours, they kind of start to get broken down. So you won't actually begin to starve to death for 48 hours. You'll get your monosaccharides out in the first 4 hours. Your disaccharides come after that. Your starches and carbs start to get broken down, which is really unfortunate because as much sugary foods as we eat and as much complex carbs and pastas and rice and all that stuff, this is what makes those low carb diets actually true. We don't care about carbs. It's the fat that we want to get rid of. That's our fat storage. That gives us our shape that we usually don't like. But to even get to the fats, you have to stop taking in simple sugars, slightly complex sugars, really complex starches and carbs, and it takes 48 hours of not having any of those in your body or burning more than you're taking in before your body will say, well, I'm out of the short-term storage with my glucose, I'm out of my kind of backup there, which is my disaccharides, and I guess I'll start using my amylose and my starches, but I've burned all my starches. I guess we have no choice but to burn the fat that's in our love handles and our stomach and our thighs and places we're trying to get rid of. So you have to completely lower your carb intake and burn carbs faster than you're taking them in. But man, they taste so good, and we eat so many carb-rich foods that take forever. So you really have to almost not have carbs for 2 days before you even start to touch the fat that you're trying to get rid of. So that's the other thing that's funny too. Kids will eat low-carb diets but still eat fats. It's like, oh my gosh. You're shooting yourself in the foot here. That's not going to do anything. You have to eliminate sweets, starches, and fats, which leaves you with proteins. That's about all you can eat. So anyway, I digest. See what I did there? This is a complex starch, a complex polysaccharide. This is a plant starch, amylose and cellulose. These are 2 of the most popular ones. You can see they're linked but not very branched. You can see this one branching over here. Most plant starches are not branched. Yes, most plant starches are not branched. Amylose is a popular one, and cellulose. The last little point I'll make here is this one about cellulose. No mammal on this planet can digest cellulose. Cellulose is a very, very popular plant starch. It's what fiber is. It's the fiber that makes up celery. It's what makes the crunch in broccoli, any of those high fiber vegetables. We're not able to digest it. So it's kind of interesting that if you've seen this, kind of gross, but the more fiber you eat, the more it passes through you. It just creates more waste when you go to the bathroom. So why they talk about eating more fiber? Well, since you can't digest it, it passes literally right through your digestive system, and it keeps your digestive system regular. If you eat foods like fats and meats and proteins, they move very slowly through your digestive system. It's not good for you. You eat a little fiber, and it keeps you regular. So, and you can't break them. You literally cannot digest them. So they give you no, or very, very little dietary benefit. You eat it and it goes right through you. And that's true for everything. You've seen this with cows. All they do is eat grass all day and poop the rest of the time. So that's kind of how these work. The next thing we'll talk about is these other ones right here.